Okay, so do you remember how on Tuesday we had a couple, well, one specifically, one series that some of you were like, well, it's almost a P series, so shouldn't it converge because it's almost a P series? Okay, so we get to actually use tests when we have situations like that, when something is almost a P series, but it's not quite. Okay. So we have two tests to add today. The first one is the direct comparison test. What I want you to do is just copy down what I have up here on the board, and then we'll fill in right here. This is an argument in every single one of my classes, and it just.
What do you think math is?
Math is all the colors. I have to have different colors.
Math is blue. Math is blue. History is not red. History is red. No, history is yellow. Science is green. Math is blue. History is red. No, it's not. Science is red.
So for me, pre-calculus is purple.
Oh, interesting.
But if you were like going back to school and you had to choose a color.
So let's say you're back to school shopping for yourself.
What color would it be?
Probably purple because that's my favorite, and math is my favorite.
No, but like
when you think about like if you were, what is it, synesthesia?
Yeah, if you have synesthesia, what color would that?
You should ask Cammy that.
Cammy can tell us.
Can you please copy this down so I can talk about it? Thanks.
History is not red. It's yellow. English is. I'm just saying like. And history is more languages.
Yeah, what?
I just went to lunch and something on my neck itched and
And now
Here we are.
Okay. A sub n and B sub n are sequences. Right now, B sub n is the bigger sequence. Do you see that right here? Like its terms are bigger. Each term for B sub n, like the first term is bigger than A's first term. Yeah. B's second term is bigger than A's second term or equal to, et cetera, et cetera, et cetera. Okay, so B sub n is the bigger sequence and its series converges. Well, B sub n is bigger, right? And it converges. So if we have a smaller sequence that fits underneath B sub n, it's also going to converge. So if you're going to use this test, if you can show me that for a fact, B sub n is greater than or equal to A sub n, and you know B sub n converges, then A sub n series also converges by the direct comparison test. Now, this comparison has to be obvious to somebody in Algebra 1. Okay. Like 1 over n is less than 1 over n plus 1. That's pretty obvious. I have it the wrong way. Sorry. Sorry. That is obvious. But other things are not as obvious, okay? And I'm not coming in with a great example right now, okay? Like 1 over 5n squared plus 2 over 2n squared. Like,
I feel like it's obvious.
not obvious. Yeah, okay. Copy this down. Whoop, sorry. Yep, this is the second way to use it. This is for a divergent. Okay, so now which sequence? Well, B sub n is still the bigger sequence, but notice how we have information right now about the series with A sub n inside. Okay, so right now, the series of A sub n diverges. And B sub n is a bigger sequence. So our smaller series diverges. So the bigger one is also going to diverge. Okay. If we have a series that converges, and we have a sequence that we can fit underneath of it smaller, then it'll also converge. If we have a series that diverges and we can fit a sequence above it, it's also going to diverge. Diverging is diverging. Can you? So are you thinking of the ones that like oscillate?
Yeah, like some.
Okay, so those are probably not something that we're going to use the direct comparison test on.
Like, for example, a function. This, like, if the sequence and is bigger than that one, you can use it.
If you're going to use the direct comparison test, you have to have something to compare it to. It's kind of the whole point.
So if I just compare it to like the sequence of stand every time.
Well, if you have something like n squared, you can use the nth term test, that the limit wouldn't be zero.
Really complex one. You just know it's bigger than n, you know, and diverges.
Because of the nth term test.
And then
Ah! Plain N. Okay, so what do you think we could compare this to? No.
1 over n. So you have to come up with what.
Yes. What's true about 1 over n cubed? Okay. A convergent P series. Okay. what's true about 1 over n cubed compared to 1 over n cubed plus 1? Okay. So this series that I've highlighted converges, and we have a sequence that fits underneath of it. So by the direct comparison test, this will also converge by the direct comparison test. Boom. Are you still practicing your writing upside down?
Yeah.
This is going to take you more energy to write than it is for you to think about it. Okay.
It's going down.
What? Do you talk about this with him also, or just behind his back?
He knows
Okay.
about it.
Okay. Okay.
Yeah.
So you've gotten to do that 5 times in a row now, right? They're on a 5-game. Okay. I'm a little disappointed.
It's not- I wouldn't call it fun, but I'd call it crazy. I got 100 on the last. Macro.
Okay. I want to use a comparison test. This almost looks like it could be what kind of a series? Yeah, we get rid of this +2 and it's geometric, right? Okay. So let's compare this to 1 over 3 to the n, which is a convergent geometric series. Okay. How does 1 over 3 to the n plus 2 compare to 1 over 3 to the n? Is it? If our denominator is bigger, then the fraction is going to be smaller.
Oh, I was comparing the other one to the other one.
Okay. So you were right. And that's what matters. Okay. So this guy converges. And the series in question is smaller than the series that converges. So this is also going to converge. Doesn't this open up some doors? Like, I didn't really want to do an integral for 1 over n cubed plus 2, but that would have been our only choice. Yeah.
The use substitution is pretty simple. Yes, I love you substitute everything.
Ugh.
I stand by.
You cannot use substitute everything.
No, on Like literally last year, she did B substitution for like every single problem, and she got like a 95 or something.
Oh, yeah.
It's probably that.
Yeah.
On like one of our rules.
I remember. That's what I'm saying. I still don't know how to algebra, so I just-
What? We're nearing the end of unit 4. So we just did the second fundamental theorem of calculus. So that's when the derivative of the integral cancel out.
I feel like these are just
And then
like
we're gonna
my-
do all of the, like the graphical analysis with it, where I give you a function, like the function is the integral from 0 to x of f of t dt. And so you have the graph of f, so you find area under the curve, or like the derivative is the actual curve. And all of that. 2 weeks ago.
Oh, really?
Okay, what do you want to compare this to? And what is 1 over n? A divergent P series, because P is less than or equal to, what was that noise? Okay, which fraction is bigger? They all mumble. 1 over n minus 1.
Oh.
This is the bigger denominator, which means it's the smaller fraction. Okay, now, this guy in a series divergence. And we have a sequence that's bigger than that. So what does that mean? So this guy.
I honestly think church
How so? Seriously?
Yeah.
Okay. To each their own. Now, what if this was 1 over n plus 1? If this were 1 over n plus 1, would this work out for us?
No.
No, we would not be able to use the direct comparison test. Okay, so either we have to get more creative, or I've got another test for you. You know what it's called? The limit comparison test. Okay, so sometimes we're gonna think, man, I can compare this, but the comparison isn't obvious, or it's not working out with like the greater than or less than. So we have what's called the limit comparison test. This is one of the best. Evan, you are by yourself and you are the most distracted in the room. Write this down so we can talk about it. So we have two sequences, and if we take ratio and it's positive and finite, then both of their series either converge or they both diverge. Did you say the F word?
No, I said not the F word, as in finite. Oh my gosh, what was the P word?
It's the F word.
Finite.
Factor. Anybody else don't get excited?
Yeah.
I'm struggling.
His friends said that
Let's have a cold day tomorrow.
Yeah.
It's gonna be cold.
It was cool.
Warmer than today. Today was already.
Today, like,
It
it was
felt
supposed
like-
to literally snow. This was like 2 weeks. Yeah, we were supposed to have a snow day Wednesday.
Yeah, all of Kansas and Iowa.
But if that's because
It just finished this whole house.
I would have to snow so that.
Okay, so we have this written down. Okay, so I'm gonna talk through this again. If we have a convergent or divergent series that we can compare to, we take the sequences and make a fraction. Doesn't care, it doesn't matter which one's numerator, which one's denominator. But you take the limit towards infinity of the ratio, and as long as that limit is positive and finite, then both series diverge or they both converge. Okay? Not infinite. Any number that's positive. No. Real. Have you ever gotten a limit to be anything that wasn't a real number or infinity? Okay, then I don't think we should worry about it. Are you writing this down?
How many more example problems?
7.
1 or 2?
Okay.
Oh, turns out this one and this one. So this one and one more.
Okay.
Okay, so this is what we're gonna do. And what catches my eye is that our denominator is polynomial. And oftentimes, if you have a rational sequence that involves polynomials, this is the perfect test for it. Okay, so I'm gonna compare to, what do you think? No. 1 over n squared. A convergent P series.
Is that yours?
It did it. Okay. Because I said series. It hasn't done it the whole time. This was the section 4 was the first time it did that. And I'm even like far away from my phone.
Oh, it's gone. It took 11 minutes.
It just like disappeared.
Yeah.
Okay, so we're gonna take the limit. The limit as n approaches infinity of 1 over 3n squared minus 4n plus 5 over 1 over n squared. Can we all just accept the fact that dividing by 1/n² is the same as multiplying by n²/1? Andre, what's the limit? Yeah. Is that real? Is it positive? Is it finite?
Yes. So if you have like 1/(n²), would you do like -n²? To make it. But if
Oh, I'm gonna teach you something here.
you don't make it positive, can you just say divergence? You know what I mean?
What?
I made that -n².
If this converges, this is positive and finite, then this converges. If this diverges and this is positive and finite, then this diverges. This triangle of dots means therefore in math lingo.
Why are there 3 dots?
I get it.
One.
Because you can make a 4 out of them. Okay. Well, this is what it is.
Can I do 4 dots?
Yeah, because the 3 is gonna confuse me.
I know, I'm gonna forget what it means.
You have to say LCT.
Oh, yes, by LCT, limit comparison test. Thank you. We always have to say which test we're using. Okay.
So it's technically yesterday, number 2 on the quiz, could we have like boiled it out, or number 2 on the back? Could we have had number 10 things? Could we have boiled out and then done this if we knew how to do this?
Except for the fact that I asked you for what it converged to,
Not.
this only tells us that it converges or
So
diverges.
we have to do that on the test. So like number 10.
It's possible.
Yes, we can figure that one out.
She still can.
What did you just say? What did you just say?
Oh.
Explain it.
It's from GTA. I don't think she played that.
Originally, that's what it's from. GTA.
Play Fortnite?
Just like GS.
Your kids?
No.
No, you kids never did.
Your kids play video games?
We have the Wii. We play Wii Sports or Mario Kart.
You can play Fortnite on a Wii.
You can.
Yeah. I have a Switch I play Fortnite.
I am trying to delay video games as long as I can.
My friends love playing Fortnite. with
Delay
me.
buying video games as long as I can.
Because if I'm like the leader, yeah.
My kids, I mean, like, we'll, they have, okay. Like, they have, Chromebooks that they'll play like cool math games on, or
It's like
my oldest son,
if his connects to Wi-Fi, it'll be like on.
my oldest son likes to look up sports stats, like he'll look up basketball stats. This is a great question. So somebody wrote this on my board, and so Fifth Hour came up with that word. It's a real word. What can we compare this to? What can we compare this to? Nope. So this is what I would do. So we have a polynomial over polynomial. Let's take let's get rid of all the garbage and simplify. What did you say? 1/n. A divergent P series. This?
this.
Like a constant, like.
Well, I'm tapping with this.
But it was like, it wasn't like Rachel's going.
Okay, so we have a divergent P series. We're gonna take the limit of our original sequence divided by what we're comparing to. Whoa, and I have into the fifth, blah, 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 over 4 into the fifth, blah, 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 blah. So our limit is 1/4. Do you see how that works so nicely? Andre, is this real, positive, and finite? All right, so therefore, oh, also diverges, sorry. So whatever this does, if it converges or diverges, then your original series will do the same. So since this was divergent, this guy is divergent. Never tried. Haven't ever needed to. I mean, if they were in a function, sure. But we might have to go check on